Another example is sodium and chlorine. When sodium and chlorine react, they will form sodium chloride. The compound is called sodium chloride. Okay, in the reverse, if the compound decompose, that means it changed back to its element here. So it is called decompose. So energy is needed to decompose, to break down a compound into its constituent elements. So sometimes it is decomposed by heat, or it is decomposed by electricity. So energy is needed in order to change the compound back to its element. So for example, for silver oxide, if it is heated strongly, it will decompose back to silver and also oxygen by heating, okay? Okay, the property of a compound are entirely different from those of its constituent element. So they are very different. So just look at these pictures. For sodium chloride, it is a white solid. But for sodium, it's a very reactive metal and can react with water explosively. So very different. So sodium chloride and sodium are very different. So one is the element, another is the compound formed from this element. So chlorine is a yellowish green gas. So they are very different in appearance and also other properties. So to sum up, the properties of a compound are entirely different from those of its constituent elements. Okay, then after talking about compound and elements, so compounds and elements are pure substance. So we can have pure sodium chloride and we can have pure chlorine. But for mixture, it is not pure substance. It consists of two or more pure substance, not chemically combined together. So mixture can be element mixture, like for example O2 and N2 mixture. They are both elements, so element mixture. And then two, element compound mixture. For example, we have what else? We have bromine, for example, bromine, and then we make with sodium chloride. So it is element compound mixture. And then compound and compound mixture. Compound mixture, for example, we have sodium chloride and mixed with water, so compound and compound mixture. Okay, so they are just mixed together without chemically joined together. They are just mixed, so without forming bonds, etc. Just chemical, they just mix together. So a pure substance is either an element or a compound. For example, if we have hydrogen, it is an element. So it is a pure substance without other stuff, only hydrogen, pure substance. And then for compound, for example, we have H2O, it is a compound. And then we don't have other stuff with it, only H2O. So we can call it a pure compound, and this is a pure substance. So then number 5, examples. So examples are alloys. It's a mixture because mixed with different metals and also some non-metal element together. Air is also a mixture with oxygen, nitrogen, carbon dioxide, very compact mixture. So the property of mixture are the properties of components of that mixture. So the mixture are the properties of the components of that mixture. So for example, for air, it has oxygen. So air can support burning because oxygen can support burning, like this. So because the mixture consists of the component like oxygen, so it will retain the properties of that substance, okay? Because they are not changed, just mixed together. So it retains the properties of the component of that mixture. Okay, here it is comparing the properties of compound and mixture. For example, we have iron and sulfur. So sulfur is S8 in the element form. And after forming, so after they mix, it is iron and sulfur mixture. So sorry, this is a little bit weird here. So it's iron and S8 here. And then after, so here is not good, okay. After forming compound is FeS. So we are comparing iron and sulfur and iron sulfur mixture and also the compound iron to sulfur. So we compare the property between compound and mixture. So compound and mixture have different properties. So here I would like to show you the videos of this experiment first. Iron and sulfur, and then after mixing it is iron sulfur mixture, and later when we heat it, it will become iron to sulfur.